Hello, welcome to the second video of how to use SPSS by beginners or first-time users. In this video, we will learn how to enter our data, how to run descriptive tests and normality tests, as well as the main focus will be of how we can run Pearson Correlation Test. First of all, we have to open our software. Actually, it's already opened, but how we can open it? We go to Start. Then if you have the icon here, you can click on it. Otherwise, you have to go to All Programs, then to open the software. As I explained in my first video, which is SPSS for beginners, the software has got two screens. The first one is the data editor that includes two sheets. One sheet is the data view where you can enter your data, while the variable view in which you can adjust or give a name for your variable. And the second screen is the output or result window. Let's start and entering our variables. For example, stock prices 1, 2. I'm going to give any numbers 3, 4, 3, 4, 3, 2, 1. Here you can see there is no clear name for this variable. So what we have to do is to go to variable view and to adjust the variable name, stock price. I got an error because we have to write just one word together without giving any spaces, as I explained before. Stock price. The second variable, for example, earning per share 20%, 10%, 20, 30%, 22, 34, 10%, and 11. As you see, there is no obvious name for this variable, so we have to go to variable view, then adjusting the name of our variable, earning per share. And now we have two variables, which are stock prices and earning per share. There is another method of how you can enter your data. For example, if you have your data already existed on your desktop, you can easily go to this option, then import your data. The name of my file is Oxford, that file I work with. Click OK. Here we can see our data was imported. So what we have to do now is to start with running the descriptive test. As I explained in the first video, this option is the most important option that you will use in your analysis. Here you can find the descriptive tests and the correlation test that we will use in this video. And here in the descriptive statistic tests also you can run the normality test to see whether you are going to deal with normal or abnormal data. So if your data is normal distributed, there is a specific test otherwise you have to run another test. We will explain in this video. How we can run the descriptive test. We click on it, then we choose our variables. I will select the capital to GDP, market capitalization, and general stock index, earning per share, I don't need the hierarchy or dividends yield ratio, market to book value, and dividends amount. Then we move it to the right. Here we will see if we need any, if we want to display any additional tests like kurtosis, sequence, variance, range, and the mean. Then we click continue, then OK, and here on the output screen we will get our results. In the descriptive tests you will find the number of observations, range statistics, minimum values, maximum values, and the standard error, standard deviation, variance statistics, and sequence and kurtosis. These techniques will be used to find whether your data are normally distributed or not. After that, we will move to run the normality test. We go to descriptive statistics, then explore, and here you can choose your variables. We will try the market capitalization and the earning per share plus market to book value ratio. We move them to the right. We go to statistics to make sure that we will have histograms in our results plus normality plots. Then continue, then we click OK. And here you will find your results, and here the histograms. Then we will move to learn how we can run the correlation test. The main important thing is to know whether your data are normally distributed or not. For instance, if you are dealing with normal distributed data, then you have to run the Pearson Correlation Test because your data will be known to be parametric. Otherwise, you have to run the Spearman test because you will deal with non-parametric data. Now we have to explain some information of correlation test. I go here to my slideshow from the beginning. Correlation test. It's a linear relationships implying straight line association are visualized with scatter plots. The strong linear correlation will be occurred when the points lie close to straight line, and the relationship will be weak if they are widely scattered or fluctuated away from the line or from the mean. When we have to run this test, when we want to know if there is an association between two variables, and these variables must be continuous or quantitative variables. The purpose of this test is to measure the direction and strength of the linear relationship between two quantitative variables or continuous variables. Here is the use formula, and you don't have to know it because this formula will be applied automatically by the software itself. Indeed, there are basic assumptions when you think to run the Pearson correlation test. The first one, there is no distinction between the explanatory, which is the independent, and the dependent variable. The null hypothesis test that R is significantly different from 0. The third assumption, the variables must be continuous variables, and both variables must be normally distributed. Otherwise, we will move to run the Spearman test instead of Pearson correlation test. The other assumption is that there is no categorical or nominal variables. Here we are talking about the categorical, which means dummy variables. And the last one, R doesn't change when we change the units of measurement. For example, if we change the kilogram to pounds. How we can interpret the correlation results? The positive R indicates that there is a positive linear association between the dependent and independent variables, and the negative R indicates that there is a negative correlation. The value of R always lies between -1 and +1. The strength increases when the value of R moves away from 0 towards whether -1 or +1. So if the value of R moves towards -1, meaning that the correlation is negative, otherwise it will be positive. The extreme values of 1 and -1 indicate that there is a perfect linear correlation between the examined variables. So the most important thing is how we can know if our correlation or the relationship between the two variables is strong, moderate, or weak. If the value of R between 10% and 30%, then we will get a weak relationship, while if it's between 40% and 70%, the correlation will be medium, and if the value of R lies between 80% and 1, then we will have strong correlation, and if this one is negative, we will have strong negative correlation, or if it's positive, strong positive correlation. We'll see now. The perfect positive correlation will be when the result of R is 1, positive 1, and here you can see the line moves from down to up, and the negative correlation, as we see in the second picture, which is on the right, the line moved from up to down, and here we have perfect negative correlation because the value of R is -1, and here we have no correlation because the points are fluctuated away from the mean or the line. How we can run the correlation test? As you see here, we will run it on the software now. We go to correlation, bivariate, which is Pearson correlation. Then we move our variables from the left side to the right side. Then we click on Pearson correlation if our data are normally distributed. Otherwise, we have to select the Spearman option. Then we click OK, and here you can see the results. And before we run the test, the most important thing is to put a hypothesis. My hypothesis will assume that there is a significant correlation between the earning per share along with market to book value. And here it's the null hypothesis, which is H0. As you see, the hypothesis postulates that there is a significant correlation between the earning per share along with market to book value ratio. And this significant correlation, it could be either negative or positive, or maybe we will reject this hypothesis at all if we got that there is no correlation. And the econometric model, which is the model to be estimated, is y equal y, which is the dependent variable, equal. Here I will bring the sample. Here is the constant term P0 plus one, which is the regression coefficient multiplied by x1, which is the first independent variable, plus the error term, where we can find the error term. It's here. No, we could put E, and T is the time. So this is a model we are going to estimate relating to our variables. The Y is the market to book value, which is the dependent variable, equal. I would easily copy this one here, equal x1. X1 is the earning per share, and here is the constant, the error term, and the T is the time. Then we go to run the test. Here we open our software. We don't need this one. Here, how to run the software? Easily we go to analyze, then we move down to correlation test bivariate, then we will move the variables to be estimated to the right side, which is here, market to book value ratio, the dependent, and earning per share, the independent. Then we click OK. Pearson correlation, we run the Pearson correlation when we are dealing with normally distributed data, as in our case. Otherwise, if our data are non-parametric or abnormal distributed, then we have to choose Spearman. But in this video we will choose Pearson because we are going to analyze parametric data. Then we click OK, and here you can see our results. Here one, there is a strong perfect correlation between earning per share and earning per share. That's fine. While the magnitude of correlation between earning per share and market to book value ratio is 7, which is very weak. So, since our result lies between 10%, actually it's less than 10%, therefore we will find that there is a very weak correlation between earning per share and market to book value. This result, in other words, means that an increase in the independent variable by this value, it will lead to the same movements in the dependent variable and in the same value. Thank you for watching, and wait me in the coming videos to explain and elaborating how we can run regression tests in Spss.